All right, it switched modes. Can you hear me? Can anyone hear me? Oh, you can hear me. Okay. It's just acting a little bit like it's hanging. All right. So our next talk is Aja Hammerly. She's going to be talking to us about playing with data with Ruby and BigQuery. She lives in Seattle, where she's a developer advocate at Google and a member of the Seattle Ruby Brigade. Her favorite languages are Ruby and Prolog. She also loves working with large piles of data, and in her free time, she enjoys skiing, cooking, knitting, and long coding sessions on the beach. So we'll let her get everything going here again. When I switch modes, it looks like it's been kicking the presenters off. So we'll give her a second to come back on, and then we'll let her give her talk.
So, title of this talk is Playing with Data, Ruby and BigQuery. So while I'm presenting, I'm working with a single monitor, so I can't see the chat. But I'm just going to try to go through the slides pretty quickly, and then there's going to be some time for interaction, probably some live coding, live demos, and just more back and forth interactive than the presentation. But I want to give the background info a little bit first. So a little bit about me. I'm Aja Hammerly, developer advocate at Google. I work in the Seattle office on Google Cloud Platform, and you can tweet at me at ThagMizerRB. www.thagamizer.com is my website, and all the code in this talk is on GitHub at thagamizer/examples. And because of where I work, I have to say this up front, all code in this copyright Google and is licensed under Apache v2, which means it's open source, but Google retains the copyright to the stuff I do while I'm working for them. So let's talk a little bit about big data. I've been to a bunch of conferences this year, and I hear about big data and data analysis and statistics from a lot of folks, but I still don't really have a good intuitive grasp of what big data is. So I understand the data part. Data is the stuff you keep in your database. Data is your log files. I actually did a talk at Golden Gate RubyConf last year about what is data and how to manage it. But the big part's a little more fuzzy for me. So if you're doing all your data analysis with static tools, big might mean a couple hundred rows. If you're doing it on pencil and paper, or maybe even just using a calculator, that's probably all that you can handle, realistically. If you're using your text editor or a simple spreadsheet tool, maybe you can deal a couple hundred megabytes. I've been doing most of my work before Google in Emacs, and if you're going to try to open a file of more than 100 megabytes, it warns you first. And depending on your actual hardware, that may or may not be a warning that you should heed. So when you put the two of them together, though, I don't really have a good feel for what makes data big. And I think it really depends on you. It depends on your use case. And anything that feels big to you, sure, it's big data. So any sort of big data talk is not particularly exciting without a convincing data set. And I've used a couple different ones, and there's a lot of, they're publicly available. There's weather data, there's data on different kinds of plants. I used the data from Aaron Patterson's website, Recruiter Spam, for a talk. But I wanted to do something a little more altruistic for this talk. So I went to the website donorschoose.org, and it turns out that they have a bunch of open data available. So for reference, donorschoose.org is a microfunding / crowdfunding / charity site. And the way it works is public school teachers throughout the US create project proposals where they write about their classroom, what their classroom needs, and then they ask for a specific set of resources. And donors from around the world can go and donate to those projects in any amount. And once the funds are generated, they've gotten enough donations, Donors Choose deals with the procurement and sending on to the teachers, and then also forwards back thank you notes and packages from the students to the donors. So yeah, earlier this week I did a quick search of projects that are near me, and these are the kinds of things that people were asking for: printer and ink, art easels, iPads, drumsticks for a music classroom, books, specifically translations / simplifications of classic texts like Huckleberry Finn for English language learners, bookshelves, rugs for kindergarten classrooms, math games and puzzles, just, everyday stuff that you'd see in classrooms. And this is just a list at the end of the school year from the area near me. Different areas of the country have different needs. And one of the coolest things about donors choose is that they have all their data publicly available. They've run some open data contests. There was actually a Ruby-based open data contest several years ago, and I got interested in donors choose when I was working at an education startup, and I became aware of their data efforts as part of my work there. So I contacted them when I was just working on this talk, and I'm like, hey, can I use your data sets publicly? And they're like, as long as you put a link to our data site, sure. So that's where the data came from for this talk today. And I'm specifically focusing on their projects data. So they've got a couple different data sets that are open. They have records of donations, they have records of their gift cards, they have records of the resources that teachers request. But the projects are really the heart and soul of their website, so that's what I'm focusing on for this talk. And, you know, that data set's big by a lot of people's standards. It's almost 800,000 rows by 44 columns. And the columns are things like the teacher ID in their system, the school ID, the National Center for Education Statistics and something else has a recognized school ID that's used by a lot of different people for their research. And so that's one of the columns. There's information about what resources were requested, how many donors donated, how much the project was, how much of that was shipping and handling versus the actual resource cost. It ends up being a fair amount of data. So, and it's available in CSV. So what am I going to do to explore this data? It's more than I really want to explore locally. And I learned this really cool tool once I started working at Google called Google BigQuery. And what is that? Well, it's a tool for analyzing large amounts of data. It was built by Google for looking at logs, but it can be used for a lot of different things. And by large amounts of data, I mean up to a petabyte easily. So one of the coolest things about it is that it's fast. It can query all of the birth records in the US for a little over 50 years in under 10 seconds. And that's select queries or aggregation queries, including math. It's easy. It uses SQL as the primary query language. So if you know at least a little bit of SQL, you can use BigQuery. And then the import formats are either CSV or JSON, which are really common, easy to get formats. In fact, Donors Choose makes their data available in that format. And the other reason I like it is the cost. So the first terabyte of data you query a month is free. After that, it's $5 a terabyte currently. And you have to pay your storage costs for the data. Google Cloud Store is what they use for storage, and those storage costs are reasonable. They're industry average or slightly better, and they keep lowering them. So I'm actually not 100% sure what the storage costs are today. All in all, this whole demo cost me less than $5 to do and run, including a month of storage costs. So that all sounds great, and I hate sounding like a marketing person, but I kind of do right now. So I'm just going to show you a demo because it didn't really kick in for me what this was like until I actually tried it out. So this is the interface. And this is a video. I'm going to show live demos later so you guys can tell me what you want to see. But if I click in here, I'm just going to look and see what the project's data is and see. So let's see how many actually funded projects there are. So I'm just going to do a count star, just get the number of rows from the Donors Choose Projects table where funding status equals completed. I'm going to get rid of that limit. And I'm going to format the query pretty, and then I'm going to run it. And this query took 1 second to run, and it gave me back 500,000 records are currently funded. So that's how many projects Donors Choose has funded in the amount of time that's available in this data set. That's a lot. And the coolest part of this is that I just searched almost 800,000 rows and summarized that data in a second. So sadly, BigQuery can't import the CSVs from Donors Choose straight up. There needs to be some pre-processing, but luckily that gives me a chance to use Ruby, so that's awesome. So the data comes in looking about like this. This is one row, and it's not particularly comprehensible, and there's some problems with it. So first of all of these Fs, those are falses for Boolean fields, but BigQuery only accepts true or false or 1 or 0 in CSV files, so those need to be turned into true, false, or 1, 0. Also, those dates. While that's pretty close to the ISO standard date format, doesn't include the time portion, and BigQuery only accepts date timestamps. So those need to be altered slightly to include a time so that BigQuery can parse those. And these triple quotes bug me. BigQuery will happily import them fine, and they're only on ID fields in this particular record, but I still don't like them, and I want to get rid of them. So I'm going to make a formatter that solves this problem. So here's the entirety of the code for the formatter. There's two main sections. The left column is the code that's actually doing the formatting, and the right column is the code that's taking in one CSV file, performing the pre-processing, and then outputting another CSV file. So here's the formatter. Now spread across two columns so that I can see it. And here's some of the basics. So this is the key part of the loop. I have a class method on formatter called format. It takes in a value and one of the supported BigQuery data types. If there isn't a value, it just returns, because nil is totally a valid value in CSV. Otherwise, it sends to the format_type method the value, and it returns whatever that method returns. And then there's some collapse code that I'll show you in a second. So, well, what are BigQuery supported data types? Well, here's the list. There's only 6: string, integer, float, boolean, record, and timestamp. Everything except record should be pretty self-explanatory. Record is a collection of other columns, other data, so it's how you would input something that looks a lot like an object type. But I'm using CSV, which makes that a little hard. If I was importing from JSON, that would be straightforward. So as far as I'm concerned for CSV, there's really only 5 data types that I need to support. So here's the formatter for string. I'm just taking the value and doing a 2s on it. Since I'm pulling in from a CSV, this is not strictly necessary, but I want to make sure that what I get back is properly UTF-8 encoded and all that, so I'm going to do this. Formatting integer is about the same, value 2i. Formatting a float, value 2f. Boolean gets a little more complicated. One of the things to clean up from that input file is the fact that they're representing their falses and their trues as lowercase t's and f's. So I'm going to take in some string value, and I'm just going to use a case statement to regex it. So if the string is equal to 1, well, that's going to be true. And if it's equal to true, t, or any capitalization of either of those, it's going to be, and I could have made this in first when a non-capturing group, but it made the regex even harder to understand. Likewise, for false, 0, f, false, or any capitalization of f or false. And finally, in the case where I don't know which one it doesn't follow either of those patterns, I'm just going to raise an error so that I can either improve my code or correct the file. And finally, here's the formatting of the timestamp. So I've got datetime.parseValue. Datetime class in Ruby is really good at pulling in just about anything, and then I'm just exporting it to ISO 8601, which is the format that BigQuery expects. So that's all great. That's the formatter, but that doesn't actually show how to get from one CSV to another CSV. So here's the processing loop. And I mean, there isn't a ton of code here, but there is some crazy metaprogramming stuff going on. And part of the reason I did this is that there's actually 5 CSV files from donors choose, and I didn't want to have to write custom processors for each of them. I wanted to do something where I could take what I knew about the column types, because they provide data saying, okay, this column type is an ID, this column type is a date, here's what this means, this one's an enum and has these possible values. I wanted to be able to use that data description stuff that they give to be able to process my files and to be able to process potentially all the different files from them. And I hope to be able to release some of this code as a proper gem as opposed to just shoving it out as it is into open source. And so I wanted to move down the path of metaprogramming and making something slightly extensible. So some basics. I've got requiring the CSV. I'm also doing a require relative on this columns file. I'll come back to that in a second. Pulling in an input file and an output file from argv, and aborting if I don't get the output file. So here's the processing function. It takes the input file name and the output file name, and it does 2 CSV opens, one for the input and one for the output. And if you haven't seen this option on CSV open, it's really, really powerful and really, really handy. This is saying not only that my CSV file has headers, the first row is a header. When I input that header, when I read that line in, the CSV class in Ruby is smart enough to store that information so that any future iteration I do over that giant CSV file, instead of just getting a line that's just an array of values, I get a line that's an array of tuples, where the first element in the tuple is the column name, and the second element in the tuple is the value. So I get the header with each and every value I pull in, which means that I don't lose context. And I also don't have to use array indexing with numbers, and remember that the third column is the school ID, and the fifth column is the school's latitude, and the sixth column is the school's longitude, I can actually get those column names and use the column names when I'm working with my data set, which is really awesome. So this is the meat of the function. I shift to pull the headers in, and I write those back out to the output file as is. At that point, I have the headers, so I can do this enumerate each line, and each line is going to be that tuple list. And I'm yielding that line to some function that's passed in as a block, and then writing it out to the output. So here's how I call it. Again, I'm just calling it with the file name and the out file, and I'm also then passing it this block. And it's a block that processes on the line, and it just maps across the line. And you see I have the column name and the value pair here. So each element in that line, each cell in that CSV is a tuple of column name and value. And then I'm just calling the formatter. I'm calling formatter.format with the value, and this project's columns with the column name. So I mentioned that require relative on the columns file earlier. And this is how I'm using that column name. That project's column is just a set of key value pairs. It's a hash that maps a column name to the correct formatter to use. So it looks a bit like this. And quite literally, that file just contains a bunch of constant hashes and saying, well, if the column name is project ID or underscore project ID, you should use the ID formatter. Or if the project name is, or if the column name is school latitude, you should use the float formatter. School longitude, use the float formatter. School city is a string. School state is a string. When I gemify this, I'm going to pass this file name, the file name that has this constant in, also on the command line. This is just a really fast way for me to separate concerns. There's one concern is formatting the file, and the second concern is getting the metadata about the data set in. Writing this file didn't take me very long. DonorsChoose makes description files available, and in the data science study I've done, it's found that most companies and organizations that make their data available provide a data description file of some sort that tells you the data types and perhaps a little more information about what each column is. And frequently that information is available as a CSV or some other format that's pretty easy to transform into a Ruby hash as well. So that's all great, and I got this all working. It took a grand total of about 30 minutes, including a refactor to make the code a little less specialized to get this working. Running it on the file took about 15 minutes. There's a fair amount of data there. And so once I had a new clean CSV file, it was time to load it up. So the first thing you need to know is that you have to store your data in some place that Google can get to it. For relatively small files, you can just upload as part of importing into BigQuery. But this was a relatively big file, and I'm making this available to some of my coworkers so they can do talks based on it too. And so I wanted to throw it up in cloud storage. There's a great UI. If you've done any sort of cloud-based storage system that involves buckets and files, you can figure it out. It's not hard at all. The other thing that BigQuery needs before I can load data in is it needs a schema. And the schema looks something like this, which is kind of a mess, but if you add some returns, all it is something that looks very JSON-ish, where you have a column name and a BigQuery data type. This also looks a fair amount like that column file, a column constant that I showed earlier. It's just the JSON version of that Ruby hash. So that's pretty easy to generate. And so here's what it looks like when you actually upload the data into BigQuery. You click on this, you're like, I'm going to go create a new project. And I'm going to pull it in from cloud storage, giving my bucket name and my project and my file name. And you can add the schema field by field. I have 44 fields, so I didn't want to do that. So I just pasted that JSON thing in, and it parses that and turns it into this interactive format. I can make some of the fields unnullable. I can double check that I got everything right. And I can click next. I'm going to say that there's one header row to skip, and then I'm just going to submit it. And BigQuery is going to process this. And you get to see that there's down one job running. And there we go. And it takes a while for this to run. I think this one took 15 minutes-ish to import. It may have taken less than that. I walked away and went and got a cookie. But it'll tell me if there are errors. It'll tell me what the errors were. And then I have the data available. So what does that look like? Well, frequently what people don't realize when they're like, I'm going to do big data on it, is that you need to have questions. You need to have interesting questions, and you need to have questions and kind of a sense of adventure and exploration about it. So some of the questions I asked about this data when I was exploring was, well, how many students have been reached by all the BigQuery, by all the donors projects? So one of the columns they have for every project is the number of students reached, and it's SQL, so I have a sum function, and I'm going to just look at the ones where the funding status is completed, the ones that are done. So the answer is 47 million. If you actually go to the Donors Choose website, the actual number is a bit underneath it because some teachers do multiple projects a year, and they've managed to account for the double counting that would come from just raw summing up the data, but there's still a surprisingly large number of students. Also, this query took less than a second to run. Here's another one. What subjects are the most popular for projects? Well, some of the columns I have are primary focus area and primary focus subject. I can do a count star again. I can make it on more things where funding status is completed, and I can group by 2 columns in this case, and order by the count descending. And that gives me something that looks a lot like this. This is actually a table I formatted so that I can fit it on this slide. But this query took 1.1 seconds to run. And copying and pasting, saving in the CSV, BigQuery allows you to save your results in CSV, and copying and pasting the data into the slide took another 2-3 minutes. Most of that was formatting. And what I find out is that by a fair margin, literacy is the biggest focus area. Math is a remote second, and another literacy, literature and writing, comes right after math. There's applied sciences, visual arts, environmental science, health and life science, music. Music was actually really close to me. One of the projects I funded was to get bass clarinets for a high school in the rural Midwest, because I played bass clarinet, and I figured that'd be a cool project to fund. So you can see all that data. You can also see that this is all of Donor Choose's data for a very long time, and some of the early records don't have these fields because they didn't have them in the first iteration of the app. Another question I had is, how many donors does the average project have? When you think about crowdfunding sites, you think about them needing thousands upon thousands of donors. So let's check that out. Known donors is another one of the fields they gave us. So we've got count stars count. We're going to group by num donors. Again, completed projects only. And you can see that the vast majority of projects only have 1 or 2 donors. And I looked at this a bit, and I poked around on the website, and this seems to be largely because organizations like the Bill and Melinda Gates Foundation, people like Stephen Colbert, frequently will go and found all the projects in a given state or all the projects in a given category completely when they have funds that they want to spend on charity. And so those projects all need only 1 donor, and as a result, they get funded. What types of resources are most popular? So teachers can request books, they can request technology, they can request trips for their classes, they can request visitors to their classes. And I was curious what types of things are requested most often. I figured it would be something like technology, because frequently technology is hard to budget. So let's look at the most common, followed by technology, followed by books. And what I see here is that, and again, this query took less than a second to run. And so that's, interesting. At this point, I'm getting really into the exploration. So let's do something a little more complicated. What percentage of projects actually end up getting funded? So to do this, I have to do nested queries, and I also have to use some functionality we have built into BigQuery, specifically this ratio to report total over, and there's a bunch of tools built in for different kinds of mathematics, and one of the things you can do is sliding windows. So the outer select is just getting me the funding status so I can group by it, and also getting, and I can see it in the results, and also getting the rate, and also taking the ratio from this inner query and multiplying it by 100 and calling that percent. The inner query is more interesting. I'm going to get the funding status for group by. I'm going to do a count stars total, same way we've been doing for all the other group by totals, and then I'm going to do ratio to report. And I'm going to say, use the total column over everything in the table, and I'm going to call that ratio. So all it's going to do is it's going to take each group's total and divide that over the total of the table and call that ratio. And so the syntax is a little weird. It's SQL. It's not an ALGOL language, so it feels a little funny. But what this ends up giving us is this data. This query, again, takes less than 2 seconds to run. And what you see here is that about 27% of the projects are expired without receiving their funding. About 67% of them were completed. Reallocated means that the project didn't complete, but the teacher used the funds on a different project, or they scaled down their project so that it could be completed with the funds they managed to get. And about 5% of the projects were live at the time that this data dump was released. So that's great. How many of these projects are funded each year? Well, that's pretty straightforward too. So if you remember right, I only have timestamps, and those are whole ISO 8601 timestamps, including time, but I want to aggregate by year. Well, we're in SQL, so there's a year function that will extract the year from the date completed, so I can just use that as my grouping. So I'm essentially adding whole columns to this table in real time without actually taking up any additional space. And I'm doing a funding status completed, I'm grouping by year, and doing ordering by the count again. So I get back the data that looks like this table, and then I just made a quick graph from this in numbers, and this is what I got spit out. And you can see that the number of projects over time is increasing. But again, even cooler, this doesn't take a whole bunch of time to run. I'm not creating a temporary table. I'm not having to do any of this math myself. It's just happening for me in the back end of the massively parallel processing that BigQuery supports, and it takes seconds. So one of my big theses, and we'll hopefully get to explore this together a bit, is that you can do big data too. You just need to know how to explore, be willing to explore, dig into the data a little bit, be willing to be surprised by what you find. You need to be curious. And you need to learn some tools that will help you out. I think BigQuery is a great one. Knowing some SQL is really handy. Knowing a really basic charting program so that you can create charts is very handy, because a lot of people don't like looking at giant piles of numbers. And maybe you should learn stats. I didn't cover any statistics in this particular talk, but I've done several others about why knowing some basic statistics and understanding the basics of statistical significance is really important when you're going to at least dabble in the realm of big data. So if you want to learn more, totally ask me questions, but there's also a BigQuery web UI quick start that I'll be tweeting shortly after I get off the talk. You can go Stack Overflow. The BigQuery label is where all the BigQuery questions get answered. We have people actively monitoring that. If you want to check out the dataset for yourself and see what you can find, data.donorschoose.org is where the data is available. If you want to see cool things that are done with BigQuery, one of my coworkers is the moderator of Reddit BigQuery. One of the cool things he did recently was he took someone did their data from 23andMe, and he downloaded their simplified genome from 23andMe and imported it into BigQuery, and then they were able to query this person's genome that he was sitting with. And it was all private. The data is not shared unless you actively share it. But it was a really cool application of BigQuery that I hadn't thought of. So at this point, I'm going to get off of my presenter screen and see if we can actually talk about the chat. So how do we want to do this?
Typically, people have been typing their questions into the chat.
Awesome.
They can also click the Ask a Question button and ask with their voice, but nobody's done that yet. So. Okay.
So let me actually get into the Donors Choose data. This is my Google Cloud Platform dashboard. I'm just gonna, here, I'll just show you the storage browser quick so you can see really truly how easy it is. I'll make this part small because I don't care about that. So my bucket is called Dagamizer because that's the name I use everywhere. And you can just upload files. It's just a real simple web UI for solving these problems and getting data up, and then it just does the upload. I can see all the files I have. I can see how big they are. So the project's data is about 400 megs. The donations data, which I also pulled up, is a little more than a gig. And that's the clean version. I also have the original versions that they gave me, and you can see that my versions, the clean versions, got bigger, and it still wasn't a problem. But we're here to talk about doing crazy big queries really, really quickly. So let's load up BigQuery. So here's the projects data set. And I'll just do an example one real quick. So I can query the table. I can see the schema at any given time. So let's actually do grouped by state. So let's do school state, count star. The limit it puts in there so that you don't do anything stupid on your first query. It's like the MySQL I am a dummy flag. I'm going to actually do total projects, not just completed projects. And we'll make this total. And order by school state sending. So you can see the elapsed time there, 1.1 seconds. And I did them by school state descending, but let's actually decide that the total is probably more interesting, so you can see what states have the most. That took a little longer, 1.4 seconds, but you can also click the Format Query button to make your queries pretty, and you can see that California has the most by a lot, which makes sense because California is one of the most populous states. So yes, so one of the first questions I see is, can the target table be appended to? And the answer is yes. I used the static updates. I uploaded a single file. You can live stream. You also append to an existing table via the API. I didn't have my notes. There's several BigQuery related gems that you can use out there, that are out there that you can use, and you can use them to do live streaming of the data in and to append to existing data. One of the other talks I do on BigQuery is about doing log data. And there are several people who figured out ways to live stream their logs in via tools like FluentD. And so their logs are always up to date and available in BigQuery with this kind of query time, this speed and this ability to process large data sets. And quite literally, petabytes of data are not a problem. So other questions, other queries you want me to run? I'm happy to look over the data set. Let's actually look at the columns again. So some of the data that's available, latitude, longitude, city, state, zip, metro, this field is whether it's urban, suburban, rural. There's one other field, one other value. There's a district, county, whether it's a charter, whether it's a magnet, whether it's year-round. So geoqueries is another question that came in. There are tools for handling geoqueries. I'm not real great at knowing that information, but that information is available, and I can definitely pass on some information via Twitter that talks about what you can do with geoqueries and BigQuery. There are people doing some really cool geo-related stuff. So one of the other cool things is if you want to try BigQuery and you don't want to, set up an account, don't want to pay for it, you don't want to put your own data in it, we have a bunch of public data available. So I talked about querying all the births in the US. That's the natality data set. This is all publicly available to anyone who creates a Google Cloud Platform account. If you have a Google account, you can create one. It's free. They give you $300 to use over 60 days, although any of the public data set querying will be free for you. And there's a whole bunch of information about the births. There's also Wikipedia logs over several years, and you can get some information on this table. That's a 35 gigabyte table. All the words in Shakespeare, actually not as big a data set as you'd think. And then my favorite is this GSOT data set of the public data sets. This is weather information. GSOT stands for Global Surface Conditions of the Day. So that's going to be the weather at a whole bunch of different weather stations in the US, summarized on a daily basis. And that's 16 gigabytes of data. And you can look for a couple information about that. Let's see some of the other ones. There's a bunch of GitHub data in here too that they've pulled in about repository information, but I haven't played with it much yet because it's not actually as interesting and as readily applicable to everyone as the weather data is. So, other questions, other comments, crazy things you want to say, and please feel free to ask questions about things unrelated to big data. If you just have questions about Google's cloud tools, I'm always happy to answer those.
One question that I have is, you said that you can stream data in, but could you actually build out some kind of analytics engine and dashboard with some of the stuff in here, or would that be a horrible idea?
I think that's a great idea. We totally have customers that are doing that. One of the things, and I'm actually working with, I have a friend who's consulting, and he's working on a smart home, smart meter, electricity app that is looking at BigQuery as one possible backend. One of the cautions I make for people to build an analytics engine across the back is to make sure that they think carefully about how much data is going to be processed by any of those queries. you do get a terabyte a month for free. And most of the queries I've been showing you have been only looking at this much data. And queries are cached, so any cached queries are free and any errors are not charged. But if you make it available to a whole bunch of people and you have a lot of data, some people have gotten into trouble with their bills being a lot higher than they expect. But if you're going to do something that's largely canned queries, maybe making stuff available to a sales team or a customer service team, or you want to do analytics on your site with a bunch of pretty standard canned queries that are easily cacheable, yeah, that's totally an awesome thing to do. I actually got into Donors Choose when I was working at an education site, and we had a huge internal analytics engine that we had to build from scratch. We basically had one dev working full time on this stuff that none of the customers would have ever seen. And if we had done, it was slow. It was slow as molasses. Some of the bigger queries took up to 20 minutes to run and come through that Rails app. And if we had used something like this and then thrown a Rails front end on it, or even just a really basic Ruby or Sinatra front end on it, it would have been a lot faster and it would have been a lot cheaper for us. We were actually paying for commodity hard drive storage. We had to rack ourselves, and we were storing up to a gigabyte of data a day. And so that added up pretty quickly. That was also 7 years ago. So technology has gotten a lot better in the last couple of years, and people are less afraid of the cloud. But I've seen a lot of ideas for cool analytics platforms on front of this. I just caution people to make sure they know what kinds of questions they're asking. Other questions, comments? Wish I had saved my, see if I have some of the cool queries that I've done. I saved one of them. So you can save your queries and you can share your queries, which is really, really handy. So here's one that I liked, was donations in the thousands by state. So let me format it so you can actually see it. Can't actually make that sidebar smaller. So that's the query. Select the donor state. I'm going to sum the total donations from that state, divide them by 1,000. I'm going to round them to the lowest, to 2 decimal places, and I'm going to call that total thousands. I'm selecting that from the donations table, grouping by the donor state, and ordering by total thousands. So I run the query. It takes 1.4 seconds. And you can see that California has the largest total thousands of donors by state. Donor information isn't actually required. So null is the next biggest. But it's really interesting to see how many mathematical functions I can run on this data in place and still get huge system. And it's all based on I'm waiting for stuff to go over the internet. So any more questions? Otherwise, I'm going to stop screen sharing. Thank you guys very much for the time. I really enjoyed doing this.
When I try and wrap up, Phil chimes in.
Into the webinar again.
No, wait this time. Okay.
Awesome.
All right. Well, thank you, Aja. It was a great talk, and definitely something I want to go play with.
Yeah, thank you guys very much. And please feel free to hit me up on Twitter or email me, Thagomizer@Google. I managed to convince someone to give me Thagomizer@Google. I'll type that in. I'm disturbingly proud of getting that. And so you guys can just ask me questions. I'm happy to answer them. I'm also happy to answer any questions related to cloud stuff in general, and if you have those. So thank you very much for inviting me. It was a lot of fun.
All right. Well, that is the end of our day.